Hi guys, so in this lecture we'll be continuing on how to determine the priority for EZ configurations. Okay, so let me start off with that. So let me rewrite what I wrote in the last few minutes of the last lecture, that we are talking about EZ priority here. Okay, and how do we determine whether we should name the compound as E or Z. Okay, so first, priority on the basis of atomic number. So the groups or atoms directly attached to carbon will be given the higher priority based on their atomic numbers. Okay, and what if the atomic number of uh, those two atoms or group uh, is the same? So in that case we will see atomic masses. So in case of isotopes, priority on the basis of atomic mass. Basis of atomic mass. Okay, so this would be the sequence, and obviously if we had O18H would be given more preference over OH. Okay, so the second point on the priority is, okay, let us first look into some of the examples for this. So if we have F and I on one side and CH, Br and Cl on another side, we will see that, okay, so in this thing, attached to carbon atom, the higher priority is iodine, because iodine atomic number is more than the fluorine's atomic number. Okay, and in this case, so the if we had CH attached with Br and Cl and F and I, this would be given more priority because of the high atomic number of iodine in all the cases, compared to all the different atoms. If we have something like this, okay, let me erase it and redraw more clearly. If we had something like CH2Cl and we had CH2Br, then which will be given more priority? So we look at the first carbon here and the first carbon here. So which is the most which will be given higher priority? Obviously this. Why? Because in this CH2 we have attached H atom, and at this CH2 we have attached Br. So Br atomic mass is more than hydrogen's atomic mass, hence this would be the more prioritized uh, group attached to carbon atom, and in this case this would be the most clearly the most prioritized group in this case, because hydrogen's atomic number is obviously less than C's atomic number. Okay, but next comes when we are comparing the atomic numbers of Br and Cl. So atomic number of Br is more than atomic number of Cl, hence this would be given more priority. Okay, let us look at third example where we have CH2Cl and CH2 and CH2Br. So we see the first carbon atom, which is this carbon atom, and on the first carbon atom two hydrogens are attached, so let us exclude that. But just after that we have a chlorine attached to carbon, and in this case we have a carbon atom attached to the carbon atom, hence chlorine's atomic number is more than carbon's atomic number, hence this would be given more priority. Okay, so let us look into some more examples. We have this and this. So how do you actually see the atomic priority when you have a double bond? So you first compare that double bond by breaking into this type of So we would do something like this. So this is just a trick we are applying just to know the priority of um, EZ. So we'll do something like Cl will come here, Cl, and we'll again replace C, obviously with all the hydrogen atoms. So with this, we actually, if we encounter a double bond, we actually break it up into single bonds, just something like this. I'll just show you one more example of the same. So if we encounter a double bond between C and O, so what we do is we make this double bond again into a single bond. Okay, one valency was OH. Let's suppose one valency was already OH. So this OH would be there, this O would come, and this O and C would be joined here. Okay. And what if we have triple bond, something like this? So in case of triple bond, just to this is just a figure we make in mind so as to compare the priority order for EZ configuration. Okay, one more example. Let us see if we have something like this, then it would be CS3 and again CH2 CS3. Okay, and if we have something like this ring, then what we can do with the ring is we will actually break this ring and again we will convert it into something like, and this ring would be O and C would be here, and again for the lower oxygen atom, again we'll just break this bond and we'll just write the exponential form attached to this in case of epoxy rings. So if you have to compare priority between this ring or this ring, so for this we will break this bond, so it will come something like, we'll just attach all the number of groups which are there till this carbon atom, so it will be C, C, O and C. For this we'll break this bond and attach everything which is there as a single chain up to this carbon atom, so it would be something like C, C, O, C. So which will be given more priority? In this case this will be given more priority, because when we see on this oxygen and on this oxygen, similarly for this oxygen and this oxygen, the nearest group attached on both is O, which is higher in atomic number than C, so this is given higher priority. Okay, so let's take one more example for this ring structure. If we have something like this and we have something like this, so which group would be given more priority in EZ? So let us break the rings. If I am going for this P atom, I am just going to write all the atoms up to here, and if I am doing for S, I will write all the atoms up to P, up to C. And if I am doing for similarly for this, I will write C, C, S, C. Okay, and for this S, oh sorry, C, C, P, C. Okay, so which will be given more priority? As P and S are same in both the cases, as sulfur is obviously having more atomic number, so this would be given more priority. Both the sulfurs will be given more priority, and the nearest atom attached to sulfur is P in this case and C in this case, and atomic mass of P is more than C, hence this will be given more priority. Okay, so let us take one more example before closing off. If we have this and if we have this, which would be given more priority? Again we have a cyclic structure, so just break the bonds. So just for the first thing we will do the trick for the double bond. So with the trick I'll get that this C should be implanted here and this atom should be implanted here, so we'll get C and C in this case, and now this bond breaking has to be done. So for this C I have C, C and C. Similarly I have the same structure for this one as well, and for this I'll just break the bonds here as well. So it will be something like 1 2 3 4 5. 1 2 3 4 5. Similarly for this carbon atom, I'm just drawing it here. 1 2 3 4 5. 1 2 3 4 5. So which will be given more priority? As we look at this carbon atom, this and these are both the same. When I go into this carbon atom, I find this here and this here. Okay, so on this carbon atom, the most priority rule is, or the most priority carbon atom, there are two hydrogen attached here, so most priority would be this, and in this case most priority would be this, because it is having further C and C attached, unlike this one which is only having H attached. So this is the most priority in this, and this is the most priority in this. Again, when we go further, this is the most priority, and this is the most priority, and here I have 3 hydrogen attached. Now let me redraw it, and here I have 3 hydrogen attached, and here I have 1 carbon attached, so this will be given more priority. Okay, so in the next lecture we will be seeing more examples on actually comparing the E and Z. These were just for comparing the two substituents which are on one side of the carbon atom. Okay, so in the next lecture we will be actually comparing the E and Z based on the priority rules which we just discussed in this lecture. Okay, till then, good luck and goodbye.